Let's go to the second question on the refraction through a glass prism. The question is derive an expression for deviation. Deviation, that is, I have written angle of deviation actually, but we have called it in the books. They can get derive expression for deviation, but full form is angle of deviation denoted by delta through glass regular prism. My dear, there is a many numerical where there is a word regular. Regular means all angle. If I take a principal section, so all the angle A, angle B, angle C should be of equal angle, that is equilateral prism, you can say, that is 60, 60 and 60. So regular prism generally is of 60, my dear. So this is a regular prism called equilateral prism, my dear. A regular word can be used for equilateral, where all the three angles are equal. Of refractive index mu, my dear, the refractive index of this glass is mu. It is already given, and this we have to prove with the help of ray diagram. So I have drawn the principal section of the prism in front of you. Now I draw the ray diagram. And the next part is state the factors on which this angle of deviation depends. My dear, we have to take care of this question because this is twice repeat in the topic. I'll tell you where and where. For this regular prism, for given regular prism, we have to state the factors for this delta after the derivation, that on this delta depend on which factors. So now let us go to the ray diagram. So as you all know that I have drawn ABC as a principal section, angle A is the angle of prism. I have written AB is the first refracting phase, AC is the second refracting phase, and I have taken the ray of light, the incident ray of light like this. So this is incident ray. Let the name of the ray I have given PQ. And here, my dear, I have drawn the normal. Okay, now they say that the normal is given as NM as the name. This is a normal ray, and this is your, my dear, you all know that this is incident ray. So and this is normal, so this is called as angle of incident on the first refracting phase. Now it will be as soon as it entered in the glass, this is a glass, this is air, and this is also air. So as soon as it entered in the glass, my dear, it will be bent towards the normal, and I told you inside the glass, inside the prism, my dear, it will be bent towards the normal, no doubt, that is a concept. But when I say towards the normal, there is a base, this is a base of prism, so it will be bent towards the, you can say the main word is towards the base of prism. So here it is bending towards the base of the prism like this. So I have bended it towards the base of the prism, and refractive index is better than water, so it will be bent better than water, this light rays. So now here, my dear, I have drawn, this is the refracted ray, my dear. This is the refracted ray. Shall I write down this as refracted ray? And this refracted ray, I am writing here. And this refracted ray is, let the name given as QR. So QR is the refracted ray. Let us draw the another normal, my dear, here. So this is the another normal, my dear, I have drawn. Let this as MM dash as the normal. You can see here. Here is an angle. This is, I will tell you all this. But here this is MM dash. MM dash is the normal. And now it is going from glass to air. It is going from, the refracted ray is going from glass to air. As soon as it will fall on this surface, it will be bent away from the normal. So normal is over here, so it will be bent away from the normal like this, that is along RS. And since this is your emergent ray, we call this as emergent ray. So the angle made by emergent ray with normal is called emergent angle, right? I can put this as a name as I dash also. Why I dash? Because my dear, let me tell you why the concept of emergent angle is given as I dash in the diagrams in most of the books. The reason is that because I can allow the incident ray from the surface AC also and emerge from the surface AB also. Please remember. So for this reason, in most of the book, emergent angle is given as the terminology to reflect as an incident only. But remember, this is given by I dash. So here E is equal to I dash. We have taken the denotion. Now let my dear, this is the first surface. So that this is a refracted ray making an angle R1. And as soon as it will fall on the second surface, the refracted ray will fall on the second surface. Let it make another angle, and that angle is R2. Am I clear? On this surface it is incidenting, right? So it is denoted by R2. By which angle this on this surface is refracted ray incident? That is by R2. And why R2? Why not I word is given? Because sir, it is a refracted ray making an angle with the normal on the second surface, and therefore we have mentioned it as R2. Or we can put it as R and R dash also, no issues. We can put it as R and R dash. So there are two different angles on the different surface AB and the surface AC. You can see in the diagram right now. So now here this is the diagram, and now the last part is that I produce the incident ray and I produce the emergent ray like this. So the produce incident ray and produce emergent ray, my dear, this both incident and emergent ray inside the glass prism you can see meet at this point. So I have given it as L, and here my dear they make an angle, and that angle is called angle of deviation. So this is the complete ray diagram. I hope you all clear that the ray diagram of the prism, that is refraction through a glass prism. So now let us go for the derivation of this delta. Our aim is to find delta. In the previous video I have defined delta. Delta is the angle between. So here again I am writing you please see the previous video. Delta is the angle between incident ray and emergent ray. It is angle between incident and emergent ray, my dear. Okay. Now let's go to the derivation for this. Now in the diagram, my dear, you all can see there is a triangle, and if I name the triangle as in triangle, my dear, can you see the quadrilateral first before triangle? So take that in quadrilateral AQMR. In quadrilateral AQMR, I hope, my dear, you all can see that angle A from figure, here I am writing from figure, in quadrilateral AQMR, angle A and this angle you can see, angle A plus angle QMR, angle A, this angle plus angle QMR is your 180 degree. I hope it is clear. Angle A and angle M, opposite angles of quadrilateral. The sum of these opposite angles are nothing but angle A and angle QMR are the opposite angles you can see. And this angle, sum of this angle is 180 degree. Everybody aware about it. Now let's go to the next part. Now this is, I will put it as equation number 1. Now in triangle, don't substitute as 60 degree here, because now we are doing the derivation. We will keep the answers in terms of A only. We will keep my derivation in terms of A only. Don't substitute any angle value, please. This is for your knowledge. I have written in the case of regular prism. So I hope it is clear. In quadrilateral AQMR, sir, opposite angles, sum of this opposite angle, complement angle, you can say angle A and angle QMR is equal to 180 degree. Now my dear, the next one here, in triangle QMR, from figure you can see angle R plus angle R dash, angle R plus angle R dash plus angle QMR is equal to 180 degree. R plus R dash plus QMR is equal to 180 degree. I will put it as equation number 2. So it's a simple derivations going on, beta. So from 1 and 2, we have, you can see if I compare 1 and 2, my dear, I will get angle A is equal to R plus R dash. That is, I will put it as equation 3 because here QMR, here was QMR 180, 180. So angle A will equal to angle R plus R dash. So this is the value of angle A, that is, it is angle R plus angle R dash. Am I clear? So I will put this as equation number 3, and now let's proceed for the next part. My dear, here you can see the light is going from air to glass. Everybody can see here the light is going from air to glass, and then further it will be emerge out from glass to air. So now, my dear, as I said, air to glass and then it is glass to air. Because of that we have a emergent ray and incident ray, and they make an angle, right? This incident ray and the emergent ray make an angle, and that angle is angle of deviation. Now, my dear, if you look the triangle LQR, look at the triangle LQR, can you see that, my dear, here is the angle I. The entire is the angle I. And here, this entire is the angle E or I dash. You can see, my dear. This is entire angle is E, or you can write I dash, no issue. Your book has given I dash, no issue about it. At the end also you can see. So now, my dear, here if this entire is I and this is R, so don't you think this angle, here I will make it, the angle LQR, this angle will be nothing but I minus R. I am writing here, this is I minus R. I hope it is clear. Similarly, my dear, here also, here on this side, I will get an angle, this angle, that is LRQ. This angle I will get is nothing but E minus R dash. E minus R dash, because this is R dash, entire is E. So this can be written as E minus R dash, or E can be say I dash. So it is I dash minus R dash. So I hope it is clear. So now, my dear, take the next concept. This is number 1. This is your number 2. And now the number 3, because from number 1 and number 2 I got angle A is the sum of R and R dash. Now let's go to the next. In triangle LQR, by using exterior angle theorem, so in triangle LQR, by using exterior angle theorem, I am sure, bachon, delta is the exterior angle. So delta is, here I am writing exterior angle, which is equal to angle LQR plus angle LRQ, that is equal to sum of two interior angles. So now here this is, therefore delta is equal to, here LQR is I minus R plus this is E minus R dash. So this will be nothing but, if I go further, this can be written as, this implies delta is equal to I plus E. I have taken I and here it is plus E, and then I have taken minus common, and inside the bracket it is minus R. So I started with R, but here it is minus R dash. Then I have taken it as plus because minus and plus is minus, and here it is plus R dash. When I open the bracket, I will get the same answer. Why I did this? Because my equation 3 is showing R plus R dash is angle A. For that reason. Therefore, my dear, here delta is equal to I plus E minus A. Since angle A is equal to R plus R dash from 3. And this I completed the expression for deviation. This is the answer for deviation, my dear. And the deviation delta is the I plus E minus A. It means you can see delta depend on angle of incidence, delta depend on angle of prism. I am not writing emergent because they keep interchanging. I will tell you all this in brief. I and E are interchanging. I will tell you because we have not done experiment, otherwise you would have understood easily. But let me tell you, if for example I am giving one example, say for 35 degree I am getting E as 45. For 35 I, suppose I got E as 60, right? So for 60, when I go to 60 as I angle or 60 as emergent angle, I will get I angle as 35. So this is keep interchanging their values, please. So while dependence factor, we don't say angle of emergent, it depends upon angle of incidence and angle of prism. And therefore there is a graph variation is given for angle of incident and delta. That is my next question, my dear. So this is what the very important concept. This is what the important concept, and this is the derivation for delta, my dear. In 3 steps you can complete, and this is the ray diagram to calculate this. Now my next question on this, in the same topic, in the same question, what is the factors on which angle of deviation depends? So here I have already jotted the formula. So now let us see, there are 2 more factors where I have not written, they are not included in the formula, but on them also the delta is depends. So let us write down the factors on which angle of deviation depends. Factors on which delta depends. Number 1, my dear, you can see in the diagram, in the formula, it depend upon angle of incidence. It depend upon angle of incidence. Please take care, my dear. It depend upon angle of incidence I. Second, how it depend, I will tell you in my next topic. Immediately next topic I will tell you. For some I it is decreasing, for some I it is increasing. I will go to that. But right now it depend on angle of incidence. Am I clear? Now next is, my dear, that is angle I. Second, my dear, it depend upon angle of refracting prism. Angle of refracting prism. That is angle A. Third, my dear, don't try it depend upon angle of emergent, because as soon as I changes, E changes. So once you incorporated I, because on the basis of I, the E will keep on changing. So my dear, these are the interrelated words. So once you decoded I, it depend on I, don't you increase the point by saying it depend on E also. Because once you throw the I from here, it will be come out as the E from this side. So for different I, we have a different E. Only at one only at one place, my dear, that all I will tell you in my next topic, I and E are equal. That time this ray will not bend like this, it will be parallel. Look at the next question, my dear. So please don't, my point is don't write it depend upon angle of emergent, increase your point and all. Because once you throw your I, 35 the E is something, then 40 the E is something else, for 45 E is something else. At one value I and E are equal, at one place. And there is a condition, there is a rule how it is equal, why it is equal at that point. But my dear, right now don't write, because whenever you write angle of incidence, say you according to that angle of emergent is changing. So it depends upon angle of incident, it depends upon refracting angle of prism, and third, it depends upon wavelength of light used. This is hidden part. I will explain when I will teach dispersion. When I will teach dispersion, my dear, I will explain this deviation. So please take care. कि sir, dispersion topic में definitely I will deal this talk. So it depends upon wavelength of the light used. In class 10th you are knowing red is deviating least and violet is deviating most. Why? Because red and violet has a different wavelength. Am I clear? And fourth point, my dear, the fourth very important point, which you cannot see in your formula, but you will see when I will go for thin or the small prism, that is it depend upon, and here also I will tell it is directly depend or inversely depend, that all is a hidden right now. But I am just writing that on what factor this is depending. So it depend upon material of prism. Material of prism. Here the material will reflect the word. So different material, different refractive index. Different material, different refractive index. So hence it depend upon Alright, of material, or you can say that is in material what? Material में क्या है ऐसा? सर आरआई चेंज होगा. Am I clear? मटेरियल से क्या होगा सर? मटेरियल ऑफ प्रिंस पे क्यों डिपेंड करता है सर? एक्चुअली मटेरियल चेंज होने से आरआई चेंज होगा. सो अल्टीमेटली इट डिपेंड अपॉन आरआई, रिफ्रैक्टिव इंडेक्स ऑफ मटेरियल. So it depends upon refractive index of material actually, which is disclosed further in my next topic. But right now you can write in according to your knowledge and depend upon material of prism. But hidden part is that sir material में क्या dependence? Sir, because of change of material, as soon as I'll change crown glass to flint glass, the material of the glass prism is changed and the refractive index get affected. So ultimately or indirectly, right now he wanted to say through this point that deviation depend upon refractive index. Okay, so this is all my topic, that is question number 2. So I hope you all clear. Now I will go for the third question, which is a strong conceptual question. Let's go for the third question of the topic.